Any issues? Okay, cool. So today we're going to get started with like smart contracts, but I'm going to like recap some of the stuff that we went over in the previous lecture. So this is kind of our outline. We're going to go over smart contracts, then we're going to cover transactions and messages. We're going to cover gas, and we're going to cover some basic solidity as well. Nick, and we're actually going to cover applications right after smart contracts. So that should be like right after smart contracts. I didn't update the slide. So a recap of Ethereum. Remember that Ethereum is a decentralized platform to run smart contracts, right? Ether is not the main goal of Ethereum. It's resistant to censorship because everything is distributed. It goes through the same consensus process as Bitcoin, or at least a very similar one. For now, ignore the implementation details of Ethereum and rather focus on the bigger picture. Ethereum has a lot of different like small details that we're not going to like worry about here because it's not important to becoming a dApp developer, and that's the goal of this course. Ethereum is kind of like a distributed Git. So we talked about the state transition machine. You can think of Git as like a state transition machine because you're making commits along the way and you're able to go back between those commits and kind of see the state transition from state to state. Similarly here, Ethereum does that, but the main difference is that Ethereum can execute code and it's distributed. So Ethereum is account-based and it's not UTXO-based. That's an important distinction. So for some of you guys on the quiz, I asked like, what's the most common type of transaction in Bitcoin? And a lot of you guys marked UTXO. So UTXOs are not transactions. They're simply outputs from transactions. They're a result of transactions, okay? So it's basically in Bitcoin, Bitcoin can also be modeled as a state transition because the UTXOs are essentially used to change state and keep track of them. Because you're using UTXOs as inputs to transactions, which then give you new outputs, and that keeps track of state in Bitcoin. Ethereum uses accounts, but it uses transactions to make modifications to these accounts. So remember that Ethereum does have transactions. Just because it doesn't use UTXOs does not mean there are no transactions. Smart contracts. So at a high level, a smart contract is a piece of code that runs on the Ethereum network. So basically, you have a network of computers on Ethereum, and they have you deploy your smart contract to this network, and the whole network is run on this blockchain that stores all the code, and you eventually have a global state transition of accounts on Ethereum that start to change the state of every single account. So how this works is you have transactions that are changing what's going on in the blockchain as a structure, and each time you make a transaction, that's going to adjust the state of Ethereum's blocks. So if you think of it this way, if blockchains give you distributed storage, then smart contracts give you distributed trustworthy calculations, and Ethereum kind of adds this layer on top of the blockchain. Right, so we store code. In different ways on Ethereum because Bitcoin just uses scripts, and smart contracts are much more complicated. So we're going to talk about that because there's different types of accounts, and we kind of went over that in the previous lecture, but we'll recap that as well. So the rationale for Ethereum smart contracts is that network consensus at the end of the day is going to remove any need for trusted parties. So that means nobody can violate the contract because there's not like a single party that's just in charge of the network. Nobody owns it. So any violation of the contract is going to require that you mess up the whole network by basically taking over the power. Basically on Ethereum, your smart contracts cannot be violated. These are essentially going to be secure peer-to-peer agreements because all your smart contracts are deployed on all the nodes on the network. And all the nodes are going to run that smart contract. And because they're all running that smart contract, how can you violate execution? The only way to do that is to violate network consensus, and that requires you to take the majority of the power of the network. So why do smart contracts exist? Like, what are the purposes? So you can store and maintain data. So that means like you can represent something useful to like users or other contracts. So for example, if you want to put a token, or you want to put like a different type of currency, or you want to mark a membership of someone in an organization, that's one way to use data. If you want to manage contract or relationships between untrusting users, that's another usage of Ethereum. So if you want financial contracts or escrow or insurance, you want to be able to lock that in, but have no like ability to disable that until certain conditions are met. That's when you use a smart contract. Another use of smart contracts is basically providing usage to other contracts. That's kind of a bit of a recursive thing. You can, for example, an example of a library on the Ethereum network that you might want to use is something called like SafeMath, and we'll go over that in the security lecture. Basically, you have to worry about things like integer overflow and underflow when you do addition and subtraction operations. And if you take 61C, this is actually not a problem in like most programming languages, but Solidity is weird. So there are certain issues that you have to worry about, and writing secure smart contracts is hard. So we often use software libraries in order to make sure that we're writing like modular smart contracts that are as secure as possible with like tested code previously. You can also do complex authentication. So with Bitcoin, we talked about pay to pub key hash and pay to script hash. Remember that pay to script hash is used for multisig to make things much easier. Similarly here, Ethereum, you can use smart contracts in order to do multisig. So that means you can have a max of, you can basically generate a total of n keys, and then you use m of those n keys to basically sign off a transaction that occurs. So that means that a transaction can be secured by requiring multiple cosigners in order for it to be valid or have a valid signature. And you can have some combination of the above. So you can make these pretty complicated. So you can combine like all of these elements and eventually come up with your token solution. So smart contracts, more technically, basically they are autonomous agents of the whole network, and they react to the external network when poked by transactions, which are often call functions from the network. We'll go a little more into that, but for now, understand that transactions are basically, for smart contract purposes, they are call functions. So smart contracts also have direct control over internal balance, contract state, and permanent storage. So I kind of briefly glanced over the minimum viable token model. Basically, Philip token is a very simple token. We didn't really go into the code, but here I can kind of talk about it. So as you can see, we have a mapping of account addresses to token balances in the very first line. So that's you're mapping addresses to unsigned integers of 256 bits, and that's a balance. Sorry, that's like kind of a dictionary. And then we have a constructor function, and this will basically initialize the contract with an initial supply of tokens to the creator of the contract. And then you can, in this constructor, we will give the creator all the initial tokens, and then we'll have a transfer function that allows you to send tokens to a recipient address. All this is doing is just taking the sender's balance and subtracting the value. And if the balance of the sender is less than what you're trying to send, then you throw an exception. You prevent the person from sending any value from that contract. So you have to be kind of explicit when you write Solidity. Nick will go more into that, but basically it's kind of a verbose language.
The throw call is basically like revert all the changes.
Yeah.
Yeah. So
yeah,
it's actually been deprecated right now in favor of calls like literally revert.
Yeah, revert. Revert is actually the new way of doing it. Yeah, that's all it means. So what do all like the, yeah. Sure. Okay, so what do all the function calls translate to? So you can see here, we talked about Ethereum being the state transition machine. So we have our block, we have our chain of blocks here, and basically what's happening is for the previous block, we're trying to generate a new block, and we have transactions that are being put on that block, and you can see there's a different like state that's occurring here in the new block. So the transaction was A sends 50 coins to B, and then the old state was where A had 50 coins and B had 10 coins. The new state is then where A has 0 coins and B has 60 coins. So that's really all it is. The function call is really just transition to a different state on the blockchain, and you're going to see that actually every single block at the end of the day is going to have a set of these transactions that are going to cause like way more complicated changes than what we see here, right? There's not just like one transaction every block. There's like hundreds and thousands. So let's talk about some applications. So I know this course has been like very like theoretical so far. I think it's important to kind of go over like the practical use cases of this technology. So there's some exciting stuff here. Gnosis, for example, is a prediction market. It's actually a decentralized prediction market that lets you make bets. We'll kind of talk about those more in depth. IPFS is decentralized storage. Argon is basically something called a decentralized autonomous organization. Allows you to kind of put your company on the blockchain and allocate shares to people. Omise Go is a decentralized exchange. Golem basically lets you have paid, like basically it does two things. One, it lets you run like nodes on your computer in order to leverage unused like computational power. And then two, it lets people like get tokens in order to leverage that computational power. So it's a little different than Ethereum because its sole purpose is literally just to allow you to make use of that unused computation. And I'll talk about like some use cases of that. And Civic is an identity platform. So identity in the sense that you can put like your government ID on like a blockchain and connect it to there. And in the future, maybe there's no need for like passports and driver's licenses. So the idea that this blockchain is like a tamper-evident database, and then you have you have like multiple parties like verifying that this ID is like a valid ID. So you might have the government like come on this blockchain. You'll have like different identity issuers come on this blockchain. Yeah.
I have a question. For example, if you like make an application for like tracking the supply chain of an industry, you'll have to build an entire blockchain for example, for each SKU or something like that to track, for example, the origin of each product.
So that's called that's something called provenance, where like you keep track of you basically keep track of all your items on the supply chain. So there's a few issues with like that use case. So basically, like you would keep track of every single item as like a transaction in a block, essentially. Like you would keep track. You basically just keep track of the state of that item, like what's happening to it as it goes like over time on the blockchain. The problem with that is that how do you prevent someone from like tampering with the item that was on the supply chain? There's no way to like validate that. One good use case, I won't talk about it here, but one really cool use case that I think actually works for this is something called Everledger. Everledger. So Everledger basically lets you, it's basically a diamond like tracking like supply chain tool. And this platform, the way it works is it takes a gem print. A gem print is basically a scan of like the diamond that's like kind of proprietary to Everledger. But with diamonds, basically when you take a scan of it, they're all very unique. So you can, it's very hard to like tamper with like a diamond as it goes across like the supply chain. And you can like verify this by just taking gem prints each time like it moves around. Okay, so like let's talk about fundamentally like what kind of applications are made, because it's not just ICOs. If you don't know what an ICO is, don't worry, I will talk about that. Basically, like we have financial applications, so that includes like subcurrencies, financial derivatives, hedging contracts, saving wallets, wills. So if somebody dies, you can like literally put like connect yourself to a smart contract. And that's kind of tricky because you have to get through all kinds of layers of abstraction in order to like figure out a way to get that information onto the blockchain that you died and that's valid information. Because think about it, if a very rich man like ties that information to like a smart contract, I'm sure there's like plenty of entities that would want to try to like subvert like his valid contract. Some other applications are semi-financial applications. So money is involved, but there's also like a very huge like non-monetary side. So you can have self-enforcing bounties for like computational problems. So like an example, how many of you have heard of like the Folding at Home project? Any of you have heard of it? Yeah. So the Folding at Home project is basically like it was basically a distributed like computational experiment where they did like protein folding simulations, which are very computationally expensive, and they basically distributed all this like computing like work to people who wanted to run like software for them, and this would do it in a distributed manner. And they would take those calculations, they would aggregate them afterwards, and they would make use of this information somehow. So if you ever had like a PlayStation, you could actually download this app. The funny thing is, like when you downloaded this app, like if you wanted to like stress test like a computer as well, this was one way of doing it. Yeah, so people would download this for like various reasons, not only to just like help out the cause, but also to like stress test their computers. Fun fact. So voting in decentralized governance is also a huge like application, and we'll talk about that because I think it's one of my like personally it's one of my like favorite like applications of like this whole system. So ICOs tend to be like the craze today, and I think we need to talk about it. So what are ICOs? ICOs basically are initial coin offerings. They allow for parties to tokenize a product, service, or idea, and you can attach it to value to it through network incentives. So the problem is today, a lot of these tokens don't have network incentives. What they'll do is they'll write a white paper and they'll say, look at our cool product. We're doing decentralized computation, or we're doing decentralized exchanges, or we're doing decentralized identity. And these are like high promises, but the problem is there's no network incentive in order to like have this token at the moment. So the only reason then you buy it is so that they can raise money. Whereas like right now, like if you hold on to like, if you hold on to like Tezos, for example, which is something known as a self-amending crypto ledger, I'll kind of like mention it later on. Basically, you can't use this token, but you have the promises that you can exchange it for the Tezos like currency in the future. So at the end of the day, you're kind of like investing in these companies, and eventually you hope to get a return through this like speculative way of doing investments. So some problems, it's really hard to align incentives when you do ICOs. So a lot of people are just kind of doing it to get rich. Like people are just like throwing money at like things they have no idea about, and it's really become a crazy market because companies are raising 300 million in the matter of like days, and it's crazy. This is like unprecedented. In fact, like initial coin offerings like surpassed VC funding this year. So this was like a month ago. So like 1.2 billion was a month ago. I think it's like now at 1.7 billion.
And how many of them are successful in the end?
We don't know because it's too early. Like all the ICOs just like happened this year, so we don't know if they're going to be successful or not. But I imagine that based on what I've read, I imagine a good amount of them will like not do well. I don't think, like at the end of the day, nothing like there's no like separation between like company and like ICO like in terms of like quality. In fact, I think a lot of the ICOs are worse quality than a lot of startups that like raise VC money. But yeah, this is like an interesting prospect. I think what's really cool about ICOs is that you can essentially like raise all your money, and you can kind of get away from the government that way. So you can just say, fuck the government. I'm going to put my business on the blockchain. I'm going to put all my capital. I'm going to just raise all my capital in like Bitcoin or Ethereum, and then I'm going to issue like Ethereum tokens in order to like give my investors like this promise that, hey, once we build our actual platform, I will give you like a token that like works for like say Filecoin or Tezos or whatever. Yeah, any questions about that? Yeah.
Wait, then what if you have to like buy everything with crypto instead of fiat?
Yeah, you have to buy it with crypto. So you have to go fiat to crypto, and then you have to go crypto to ICO like token. Yeah, any more questions? Cool. So yeah, another thing I want to mention is like this is gonna, I think, lose value when the SEC like starts to regulate it. Mainly because like if you can't put your business on the blockchain and you're not really getting like you're not really getting like the biggest benefit of like going through an ICO, which is like one, to avoid taxes, two, to get people who aren't accredited investors to fund you. And it's different than crowdfunding, mainly because in crowdfunding you're just raising funds for like a product, but there's no like ties to it, and there's no like market that you can just like exchange your money on afterwards. So you can't like gain money by like putting your money in a crowdfunding like Kickstarter, right? Yeah.
So creating an ICO in the US right now is starting to get more regulated and almost like not allowed.
So not quite yet.
Not yet, but it will happen.
So China did like an ICO ban. I don't know if you guys heard about that. Right now the SEC is kind of like iffy because they mentioned the DAO tokens were securities. I'm going to talk about the DAO attack if you guys don't know what I'm talking about. But basically they made a precedent that one of the most recent hacks for a decentralized autonomous organization token, those were determined as securities because, well, I don't really know why, but that basically changed the whole game. And basically now that the government is starting to get more involved, I think that actually I won't say it. I won't say it. I'll say it later. Okay, so these are some of the ICOs that have come out. So Bancor is basically a smart asset platform. Basically, it's smart assets in the sense that you can basically buy Bancor tokens that are linked to some kind of other currency, and this allows you to be more liquid with your currency because it essentially is a contract that ties Bancor tokens to like a reserve of sorts. So this ICO kind of, I think, has a bit of problems. There was like a really good blog post on the blog called Hacking Distributed. You can check it out. Filecoin, that raised 250 million. They only did like institutional investors though, so that's kind of whatever. They do decentralized storage. They use IPFS, but basically Filecoin is the token for IPFS. Status, that is a decentralized like browser, like a decentralized almost like world essentially. Like you have a decentralized like messaging platform, you have a decentralized like internet browser, you have a decentralized application platform. Status is trying to be like the whole like ecosystem for that. And they have a mobile app actually, so you can like check it out on mobile. Here it's pretty buggy though. EOS is essentially the next generation Ethereum supposedly, but I think it's like horseshit. Like it claims to solve a lot of the scalability problems that the Ethereum Foundation has solved, but to be honest, these guys have not done like any work in my opinion, like compared to the Ethereum Foundation. Tezos is a self-minting crypto ledger. So I don't know if you guys have heard of the Bitcoin block size debate, but basically a lot of people like were fighting over like how many like transactions, or, like how much data should we be able to fit inside of one block. Basically Tezos is trying to fix this by making it so that people in the network have way more power in terms of determining this, and that way people can come to consensus on this way faster. Because for Bitcoin it took like a year, and that's like way too long. So Ethereum like market cap started rising, and people kind of got pissed about that. So then you have Tezos to like fix that problem. Yeah, these guys all raised like a fuck ton of money in like a short amount of time. So an example that I kind of like, basic attention token. So the idea is that users have been like employing ad blockers because they hate ads, right? Like how many of you use ad blockers? Yeah, see, like everybody hates ads. Okay, so you pay publishers for doing good ads in this. So the way this whole like network actually works, this whole protocol, is that publishers will get paid for good ads, and users are going to get paid for ads that they choose to watch. So basically, this is good for the advertiser because they get accurate stats, and this is actually like aligned through the basic attention token. And the token is needed because you need like a decentralized way to issue like money fast, and this is like one way to do it. The token kind of like links people in this like network of incentives because it cuts out the entire like middleman prospect. So I won't go too into depth into like the technical implementation because some of these are like ridiculous. So an example, like a really simple example that you might have seen in the white paper is something known as smart assets. It's literally just a token system. So this is actually super simple. It's literally just a database operation. So basically, an example is when you want to ensure Alice has enough money and that she initiated a transaction. So you subtract X from Alice and you give X to Bob. So this is like an old Serpent contract. Serpent isn't used anymore. We use Viper or we use Solidity in this class. But yeah, it doesn't look that different in Solidity. It's literally just a subtraction operation. Okay, a cool thing that some of our colleagues did at Blockchain at Berkeley, they went to TreeHacks and they won an award from this VC fund, which is kind of cool for this product. It's called Ether on a Stick. Basically, it allows you to put some kind of a bounty on an arbitrary task. So people will pool money together into a smart contract, and it only basically gets paid out to a recipient if the contributors vote that the task was like completed. So you pool money together, and then you give the contributors voting power to determine whether or not that task was completed, and then the payout is given to the person who completed the bounty. So a use case of this that's I think is very interesting, and that would be more usable for like third world countries, is you have a company that decides, okay, we don't give a shit about this local river because it's a public utility. So we're not going to clean it up despite polluting it with like say it's an oil company, right? Like there's a huge oil spill, and they're not going to clean it up because they don't care. They don't really care about the local community or residents. And the local government just doesn't want to do anything about it. So the community members decide, okay, we're going to pool a lot of money together, and we're going to give the government or company incentive to clean it up, right? So basically, they take the initiative into their own hands. They give them a smart contract, and basically, they only pay out if the task was completed, right? They're going to vote if that task was completed. So this solves a free rider problem where basically people will kind of just like trash on public utilities because they aren't like putting up any money in order to use that utility. So here, the privatization of like the river kind of goes into the hands of like the community because they're putting up money in order for something to be fixed. It's like public restrooms, right? Like people don't give a shit about like public restrooms, but when you have to like pay for a public restroom, which is like what you have to do in SF or like Europe sometimes, then then the standards tend to get a little bit better, but not the best still. Okay, so another example is that you can have smart energy grids. These are like, imagine that you have like a power source and you're like starting to generate a good amount of power from like your solar panels, and you're storing it, but you're not using all that energy. So the idea is that basically you create a network where you can like share this unused power, and basically a community like can connect to each other with power, and they can become more efficient overall by leveraging that unused power that you've like generated through like solar and like maybe stored in like a Tesla like battery or something on your power wall. So the only problem with this is that you need to set up like a bunch of infrastructure. So that means like you need to connect everybody's home, like in terms of electrical power. You need to be able to send electricity in and out between all like nodes in this network. So the solution to this is that you can kind of set up a contract for financial commitments. Then you can use the blockchain as like a coordination layer, which is kind of interesting. And then after that, households can then like coordinate like building this whole like infrastructure without like having to like go door to door and like start coordinating with each other and like hire a middleman and figure it out. They kind of agree. So another thing that I really like is decentralized internet. This is Blockstack. Blockstack is not built on Ethereum. Keep this in mind. It's actually built on Bitcoin, but you could build this on Ethereum. Like it's kind of you kind of like fit this analogy to Ethereum. So the idea behind like decentralized internet is that you have like there's a lot of points of failure. You have like DNS servers that can just be DDoSed, and you can like fake certificates. So there's a bit of a problem with like the public key infrastructure, and end user data ends up being stored on like centralized servers. So there's like one point of failure where like everybody can just attack, and there's no like standard way of like securing things that people know about that they can like trust. So for example, like Yahoo lost like 5 500 million like credentials in 2016. Like that's ridiculous. Like why is this happening? So the solution to this is that we decentralize the internet. It has three components, right? You have a blockchain to bind digital property to like domain names to like people's public keys, and you have a peer network. So that basically will allow you to have a global index of like information that you can use for DNS. So you can use like a DNS zone file in order to like map people's IP addresses to like domains and get to their like websites or whatever. And then you have a decentralized storage system. So that would be kind of like IPFS or anything that's kind of like practical in terms of allowing people to store data on their computers and use that unused like data and yeah, kind of. I haven't actually watched the full season 3, so I actually don't know like what happened with the decentralizing thing. Yeah. So decentralized autonomous organizations. So these are kind of a big deal. Basically, it's an organization that's entirely governed by code. That's kind of crazy. The reason is because people, like you just have a decentralized network of people that are just going to vote and create proposals. You're going to have people that are going to be able to start businesses this way. So you can like allocate shares to people. There's a huge uncertain legal status to this though, so you have to be a little careful because companies are going to want to regulate you, because if you're in their nation and you're using their like roads and you're using their like land and that kind of stuff, they're going to try to find a way to tax you. And one of the big philosophies behind this is code is law. Like you shouldn't be able to violate what's been written in the code, mainly because people's votes, and the only way to like kind of violate this is if you mess with the code. And the reason why that you need to believe that code is law is because if you violate the law, then like this whole governance system isn't going to work. So some issues, again, like I mentioned, it's hard to edit the governing laws once deployed. So if you decide that you are going to try to like edit what's like happening after the fact, it's very difficult because you're dealing with people that have voting power in this network, and they're not going to want to give it to you unless you have a very, very compelling reason. There's also like the problem of inactive participants in this network. So you might have like a lot of people just like not vote on the proposal at all. So one of the biggest like DAOs is called The DAO, and basically it was a crowd venture fund. And the idea is they pooled money together and they would like invest in projects that were like really interesting. So they pooled like 150 million Ether, and they got hacked in June 2016, and they lost about 60 million. And that was 10% of Ether's market cap at the time. Yeah.
So what's your take on the mutability aspect?
Yeah. So when they hard forked, I mean, yeah. So we didn't talk about what a hard fork is in this class. That kind of comes from blockchain fundamentals, but basically the idea is that you create a separate chain that now starts to reject like any transactions that are published on the original chain, and the original chain just remains. So the idea was that Ethereum basically created a separate chain from a period back in time when the DAO was not hacked. And my opinion on that is, I mean, if they didn't do it, I'm not sure that Ethereum would have had the adoption they did today. And because they did do it, I think they got pretty lucky here. They got very lucky.
Like if it happens on one side, like
So it kind of did.
take away from their credibility.
Yeah. So it kind of did, right? There was the Parity like multi-sig wallet hack. To keep it brief, the idea was that they basically wrote a constructor that was essentially public, and people were like starting to brute force through like people's private keys, and from there they were able to get into people's wallets. And once they did that, they managed to steal, I don't remember how much they stole. I think they stole like 30 million out of like the total like 120 million that's stored on Parity or something like that. But that was kind of like another version of the DAO. What ended up saving it was like a bunch of white hat hackers who basically stole all the other like wallet credentials on like Parity before the hackers managed to do it. And actually, I was at a boot camp where those guys managed to do that. which is kind of crazy. It's just like totally random. Like, we're gonna go save the day. We're gonna go save like $90 million. Well, you guys all work on Ethereum. Yeah. Some other DAOs on Ethereum that I think that are important. Slockit. Funny thing is, Slockit is actually like fun fact. Slockit is actually like derived from the DAO. Like, a lot of the founders of the DAO, I think some of their reputation got tarnished a bit, but they basically went over to Slockit. And the idea is that with Slockit, you can have this universal sharing like network. Basically, like, imagine you could like decentralize like Airbnb. You just put a lock on your house. People pay like to that lock, and then that lock opens, and boom, there's like your money. There's like your money for that person like staying in your house. The only thing is, like, how do you kick someone out of your house after that point? Then it's not really autonomous anymore. So there's a bit of problems with like the whole logistical overhead of this. Another thing, another DAO is Digix. That allows you to store gold on the blockchain. And there's Argon, which allows you to manage like company shares. So you can basically, there's like this user interface actually with Argon that's pretty cool that lets you just drag a slider and give someone like X amount of shares for their like product. So prediction markets, these are basically crowdsourced decentralized betting on like events. The idea behind this is that you can basically go to the wisdom of the crowd, and then you can get someone to say, some person is going to like win an election, and the people who guess correctly are given like tokens, and this acts as like a reputation mechanism for them to continually guess correctly and be honest like actors in this network. You can do some other things, like you can incentivize honest hackers by like saying like you can vote no that your company will be hacked, and then now you're putting up money for like hackers to go out and like say, I'm gonna like actually like reveal the hack to you, and then I'm gonna like get all your money because like because you're gonna be wrong and I'm gonna be right. So I'm gonna not only get the people that say yes on this, but I'm also gonna get the people that said no. So I'm gonna like all that money is gonna get pulled together, and then I'm gonna be able to like multiply my earnings that way. So some benefits to being decentralized: there's no restrictions on market creation. There's a shared liquidity pool, so this is like a borderless like system. Like there's no reason why this should like exist in like other countries, right? And you can do much more advanced like versions of these markets. So you can do like combinatorial prediction, which means like you can have prediction that depends on other predictions, which depends on other predictions, and get really complicated. This is also like censorship resistant because it's decentralized, and you can automate a lot of things this way. So some limitations. The main one is that oftentimes if you want to get information like outside of the blockchain, there's no like trustless way to do it. You have to rely on like some like king entity to say, okay, I'm going to give you like information that's been like pre-validated, or I'm going to give you information that's been like voted on previously. But basically, you are like depending on like a centralized entity to like verify something's true. And even if you have like an Oracle network that decides we're going to vote on this, it's not really going to work out because people can vote wrong in the Oracle network, and people can kind of subvert that unless the incentives are aligned. You can like hope it works, but you can't like guarantee 100% of the time that it's going to work. And there's also no way to implement on-chain credit systems on a blockchain. So you cannot do like bonds, you cannot do loans because money has to be like held on the chain, and that's for like security reasons. Like you can't just like promise like money ahead of time and collect interest and hope it works. Okay, so I'm gonna hand it off to Nick.
Okay, so quick refresher from last week. Unlike Bitcoin, the Ethereum network leverages accounts, and there are two types of accounts. First one is externally owned accounts, and note that both can hold an Ether balance, but externally owned accounts, the main difference is that they're controlled by private keys and have no associated code. So what is an externally owned account? It might be an account held by someone like you or me or an organization, basically someone that is not a virtual entity on the network. And then the other account is the contract account, and it has an Ether balance. It has associated code, so it is controlled by that code. As mentioned earlier, code execution is triggered by transactions that change state in the blockchain. And it maintains persistent storage, so it can maintain certain types of data, unsigned ints, strings, etc., etc. And I'm sure you saw that when you were working on your homework. Okay. And now, one thing to note is that there are two different types of transactions. What we'll call vanilla transactions, and the other one we'll call messages or internal transactions. Now, the vanilla transactions have to be executed by an externally owned account, and they may trigger subsequent transactions. So it's a common misconception that contracts can't fire their own transactions, but so they can. But the only difference is that if a contract were to fire a transaction, it needs to have received a transaction first from an externally owned account. So that's what we mean by all transactions must originate from externally owned accounts. So for example, if I have two contracts, and one of them is a verification contract that verifies my identity, and the other one is the contract that actually stores my balance, I would send my balance to the verification contract, and then that verification contract would update the second contract that stores the balance. I hope that made sense. And transactions and active state, an active change in state. That's important to note because in contrast to that, messages don't do that. Messages are just internal transactions. They're essentially function calls. So you would you would call a function that had the constant keyword in its title, and it would just return a value. It wouldn't change any state variables. The graphic here is just interesting to note because of the volume of transactions that have recently increased. You can see that basically most of the activity has happened in 2017. Exactly what's stored in each of the transactions? Well, you can see that with vanilla transactions, you have a sender ID, you have a recipient of the transaction, where it's going to, the amount of way you're sending, the start gas, which is the maximum number of computational steps. We'll talk about that when we talk about gas. Same with gas price, which is the fee that the sender is willing to send, and an optional data field. And messages also contain the sender, the recipient, the amount you want to send, and an optional data field. And keep in mind that a lot of people, when talking about messages, call them transactions. There is a distinction. Now, the optional data field is interesting, and you don't have to use it. But the use case for that would be something like a domain name storage contract, right? Where you want to be able to send the domain name and IP address. Well, that's where you'd put it. It's just for arbitrary data usage that the user can specify. Okay, so just take some time to log attendance before we continue. Yeah.
It's on the board, so.
Are there any questions so far about transactions and accounts? Okay. So we're going to talk about gas, and gas is a unit of measure that specifies a cost for each transaction. So each function can be broken down into opcodes. So for example, add has its own opcode. Subtract, multiply, they have their own opcodes. Opcode is short for operational code. So if you've taken 61C, you should be familiar with that. And gas is used as a workaround to the halting problem. Now, the halting problem states that you can't know in advance whether a function is going to stop or not. So, for example, if I wanted to DDoS the network, I could make function calls to a contract with infinite loops, right? If gas didn't exist, everybody on the network would have to run those infinite loops ad infinitum, right? How gas fixes that problem is that gas is consumed as you run down the contract. And so by the end of it, if you have no gas left and the contract has not reached completion, then the contract stops operation and all changes are reverted to the state. Your transaction is still valid, however, and you lose the money you put in. So gas is used kind of as an incentive to, or as a disincentive from spamming the network and attacking the network. Another thing you can use gas for is you can specify that you will pay a certain amount per gas, and obviously the higher the amount of gas, the amount you spend per gas, the more likely it is that a miner will include that transaction in their block, and the faster your transaction will be validated. More specifically, start gas is the number what you specify at the beginning. So you're going to send in a transaction with start gas and gas price, which is the amount of ether you want to spend per gas. And the start gas will have to be able to run through the entire contract. And if that doesn't happen, well, as mentioned earlier, the changes would revert and you would lose the money you put in. Okay, any questions so far?
You said the miner would still get the gas price fees, right?
Yeah, so the miner still gets their mining reward from that, but you lose the money. Okay. So here's just an example. You start off with 15, and say the add opcode requires 20. You can think of fuel as gas literally as the fuel that like powers a car, and you're trying to run a car down a function, right? And so you call greet. This is a function from your homework, and it doesn't work, right? You get an out of gas exception because you haven't inputted enough start gas. So you would lose the amount of ether per start gas, so 15 times the amount of ether you specified as the gas price, and you would make no change to the state. Whereas in this situation, you specify 21 start gas, and you the function executes, so you do the addition operation. Okay, and greeting is returned. Question?
What happens to that one remaining gas?
So you get a refund on that, right?
So is the gas, like the amount of gas that you use, is that like the number of assembly instructions that are executed or something like that?
Right. So later on, there's a chart that keeps track of the gas cost of every operation, and for the most part, it stays pretty constant. Right. Actually, that's important because the rationale behind that is that gas prices should always remain the same, and that's kind of weird, right? Because ether fluctuates, and so it's really decided by the market, if that makes sense. Okay, so we're going to talk briefly about the EVM, the Ethereum Virtual Machine, and that's just the execution environment that Ethereum runs on. If you guys are familiar with JVM, it's the same thing, the Java Virtual Machine. And each node needs to run the EVM on the network. Nodes will go through transactions listed in the block. They are verifying and run the code as triggered by a transaction. So every full node basically needs to run the transaction in order to verify that the result is the correct one, and then the change occurs on the network. The benefit to this is that the EVM is deterministic. So 1 + 1 will always equal 2. There are no mutations. There are no strange occurrences that may happen. One computer, if they calculate XYZ, a second computer will also calculate XYZ. There's no strange occurrences that may happen. And yeah, this is the chart I was talking about. It's taken from that link, and it's based on the yellow paper. The yellow paper is, in contrast to the white paper, just a more technical, more in-depth version of what occurs with Ethereum. And I just included a screenshot of that, just so you can see. If you're ever worried about the specifics of certain opcodes or specific implementation details, just reference the yellow paper. Okay, so how gas works. We talked about refunds. Yeah. Well, you basically answered that question in the back there. Right, and two more parameters that we need to specify. Gas used, which is the total amount of gas that is consumed by the transaction, and gas price, which is the price that the originator of the transaction is willing to spend per gas. And the equation is pretty simple. The total cost to you as the originator is just the gas used times the gas price. More specifically, the gas used is the start gas minus the gas unused, so left over by the end of the transaction. I hope that's not too confusing. It's also important to note that we don't really use the denomination ether when executing transactions on contracts. We mainly specify things in way, and one way is basically 10 to the 18 ether. This parallels satoshis, which are 10 to the minus 8 Bitcoin, and they're basically like the cents of a dollar. That's the parallel. Cents, quarters, dimes, things like that, and you can see them right here. Fun fact, names like Finney and Szabo and Wei, well, Wei and Finney were basically cypherpunk heroes from back in the day, and Nick Szabo is also quite well known in the crypto space. He was the first one to come up with the idea of a smart contract. Okay, so just to paint a better picture, the default gas price, so usually the average gas price that people are willing to spend for Ether is 0.02 microether, which is the equivalent of the numbers you see on screen. I just included a dollar amount so you guys can get an idea of how much a transaction will actually cost to you as the originator of a transaction. Okay, so this is a basic summary if you guys need to refer back to it. Okay, so mock scenario, assume you want to subtract and sub costs 0, and then you want to check if a certain number is 0 using the is0 opcode, which consumes 5. So you're going to subtract and then check, and you specify start gas of 20 and a gas price of 0.02 microether. And those are the only two parameters that you need to specify in a transaction. So what will happen is you'll start with 20. The sub will take up 3 of that gas. The is0 opcode will take up 5 of that gas. You'll be left with 12 by the end. So 12 times the gas price you specified will be refunded to you. And what you pay is 20 minus 12, which is 8, times the gas price, which is 0.02 microether, which is that amount right there, 0.16 to the minus 6, 10 to the minus 6. Yes?
So at what point in this process does the ether leave your meter?
I'm sorry, does the ether? Oh, you would send it in the transaction. Yeah.
And it would come back to you in the future?
Yeah, by the end of the... So actually, interestingly enough, in the yellow paper, it notes down how the amount of time it takes for each opcode to run. So if you're ever in doubt, just check that. Okay, so there's one last thing called the block gas limit, and this is what determines the amount of transactions that can fit in a block. So say you have 5 transactions, one costing 10, one costing 20, one costing 30, and 40, and 50. And the block gas limit is 100. Well, in that scenario, you can only include the 40, 30, 20, and 10 value transactions. You can't include the 50 because those transactions sum up to 100. You can alternatively choose to include the 50, 40, and 10 transactions and leave out the 20 and 30. That's basic addition. I hope that made sense. The current block gas limit is hovers around that number right there. It recently jumped from about 4 million. Yeah, miners can choose to change this. It's decided by the different nodes on the network, but most people just let it run with the default settings. Yep. So we actually do have a demo, but I know we're slightly over time. Do we want to end it? Or should we keep going? Yeah. Okay. So we're gonna end it here. We're gonna release the video with the demo inside. And just feel free to watch that if you're ever confused about the more complicated sides of Solidity. Thank you.
Wait, what is the quiz?
I'm sorry?
You said quiz answers were released at 11:30?
Yeah.
Yeah, I'll release them now.
That would be.
They're actually on my laptop. That's why I could.
Okay. Feel free to come up to us with any questions.
So how do you know how much GAA is a transaction?